So basically, video annotations. You know, it's a problem in the world. How do you have lots of video? How do you do fast, robust video annotations? So they developed a game with a purpose here to actually help capture the video annotations. But it needs to be at a large scale, lots of users, lots of clicks. So you'll see that in a minute. But there's a challenge. How do you handle all that data? How do you actually put it together? And a lot of the data is also noisy. So state of the art where things are, there's been many games of images, still images, that have been around today, but they don't handle video in a sense. So then there are different video games out there, but they're not very scalable to many users and very large data. So the authors here came up with this approach. Basically, be able to use crowdsourcing to be the first, what they've found out to be the first crowdsourcing game to actually handle interactive video with segmentation. So they need to come up with a simple web game to engage the users, make sure they stay engaged in many different levels. A simple approach so that it's not complicated, people will get avoided, and then a simple processing approach, a mixture of Gaussians to actually detect reliable background and foregrounds, and overall simple object detection. So the game here, called Flash the Fish, allows you to log on, play games, many levels, challenging. I played it myself. It's kind of a fun game. So they've come up with a way to actually come up with determining the features of both the background and the foreground, with the foreground being the user's clicks. They're using expectation maximum for Gaussian mixture model, and then they develop a background and foreground model and then determine an output segmentation. I'll see that in a second. So a few of the challenges: pre-processing. You know, there's a user interaction, so you have to be able to account for when you clicked and what frame you're actually processing. So they determine the average number of delays, frames, to compute that in the results. They determined a feature vector for all the positions, all the pixels that were selected, and a combination of hog features, color, and then the user clicks basically are generating a foreground model. And then they have a dense sampling of a background model, 5 times the number of users' clicks. Here's an example of a frame. In the left is basically the raw image. The center one is the user clicks, but a couple frames later, 2 frames later in this case, because we allow for the human interaction, and then the background model on the right, just random points. So they needed to determine a likelihood of a pixel falling either in on the background or on the foreground. So determine using the expectation maximization algorithm. They set up a segmentation mask to figure out whether pixels are going to be on the foreground or background. And this is that same example, but showing using the current frame, user clicks, you now end up with a binary mask of where a segmentation of where the annotation is. So you basically, the users have fed into an annotation model. Performance analysis, they've used 2 different data sets, an underwater data set and an I2R more generic data set. They computed the F1 measure to measure the performance, and actually in kind of a way to keep people playing, they offered a $100 Amazon gift card and to get the users in. So this is some of the data. Lots of users. They had 290 users, 11 million clicks, but and there's actually 7 different levels in the program. It gets harder and harder as you go up. It gets more complicated, faster and faster. Some objects are blurred, bad lighting. So as you get higher and higher, they had less people getting that high, so their F1 measure dropped. Experimental results from the underwater data set were very good. Overall, they blurred imaging, complex lighting, very complex environments. Their results were very good compared to other solutions. And the same with an I2R data set. They have very good results. And this is actually some of the I2R data sets using mall scenes, people scenes, and developing the masks. And conclusions, simple but effective to collect video annotations. It's a nice way to actually produce this data quickly, and just by clicking, interactive user interface, and kind of fun for users as well. So